A 2.25 gram sample of a compound containing carbon, hydrogen, and oxygen was burned, producing 4.95 grams of CO2 and 2.70 grams of water. We're going to find the empirical formula. So this 2.25 gram sample, that 2.25 grams is going to equal the grams of carbon and the grams of hydrogen and the grams of oxygen in this sample. Like the last problem, we're going to get this from CO2. We're going to get this from the water. And as for the grams of oxygen, if I know this and this, I can get the grams of oxygen by subtraction. So let's start this. 4.95 grams of CO2. Of the CO2, 12/44 is still carbon. And that's based on the molecular weights. So 4.95 times 12 divided by 44 gives me 1.35 grams of C. To get the grams of H, 2.70 grams of water. Of the water, 2/18 is hydrogen, giving me 0.300 grams of H. Now, 2.25 is the total. So if I do 2.25 minus 1.35 and minus 0.3, I am left with 0.60 grams of O. Now, I have the information I need in order to do an empirical formula problem, as in the previous ones. I'm going to erase this over here to give me more room. So 1.35 grams of C divided by its molecular weight, 0.300 grams of H divided by its molecular weight, 0.600 grams of O divided by its molecular weight. 1.35 divided by 12 gives me 0.1125 moles. 0.3 divided by 1. 0.6 divided by 16, 0.0375 moles. Next step, divide by smallest, and I'm going to divide all of them through by the smallest. So, divided by 0.0375 gives me 1. 0.3 divided by 0.0375 gives me 8. 0.1125 divided by 0.0375 gives me 3. I have all of my subscripts now, C3H8O. Remember, if you don't get a whole number here, you get something that ends in 0.5, you have to double all of them. Ends in 0.33, you have to triple all of them. You're going to need to figure out whatever you need to multiply all of them by so that you get whole numbers.